Hey guys, welcome to Conceptual Geometry, Lesson 5.6, Equations of Lines. The first equation of a line we're going to talk about is the one you're probably most familiar with, slope-intercept. That's this one right here, your good old y equals mx plus b. In that equation, m equals the slope, and b equals the y-intercept, which simply means where the line crosses the y-axis. Well, the other version that we have, and this might be new to some of you, is called the point-slope equation of a line. So point-slope looks like this. M is still slope, but x1, y1 is simply, I should say, any point on the line. And then down here, I don't think we have to worry about it until we get towards the end of the unit. If it's a multiple choice question, you might have to go back and forth between. So if I give you this version, you might have to clean it up algebraically to make it look like that. Okay, our first example, it says write the equation of a line whose slope is 2 and passes through the point -3, 6. So here's what we have. Slope is 2. There's your m. And if I give you a point, I give you x1 and y1. So we're just going to look at this equation right here and plug those in. The 2 goes there, the x1 goes there, and the y1 would go there. Now, I normally don't write all of this out, and you'll see what I mean here in a second. Y minus the y coordinate, which is 6, equals m2 times x minus the x coordinate, which is -3. I don't like leaving it like this because of the minus -3. So kind of like what we did with slope. And you can do this in your head first time, but I usually will make that a plus. So I'll rewrite that as y minus 6 equals 2 times x plus 3. That's just a little cleaner version of that. Example 2, write the equation of a line whose slope is -4 and whose y-intercept is 5. Okay, well, if I give you slope, I'm giving you m. If I give you the y-intercept, I'm giving you b. So if I'm giving you m and b, I want to use this equation, right? There's your m, there's your b. You just have to plug them in front of the x and then tacked on the end. So this is really pretty simple. Y equals -4x plus 5, and we're done. Next one, write the equation of a line that is parallel to the line y equals 1/2 x minus 5 and passes through 4 -3. Well, we're adding a layer of complexion to this by saying parallel. But all we need to remember, and if you look on your formula sheet, you'll see this, parallel means equal slopes. So now I need to look at this equation, figure out what the slope is. Well, that's going to be 1/2. And here's my point, so there's x1 and y1. So all I need to do is plug in that m, that x1, and that y1 into my point-slope equation. So I have y minus the y coordinate, so that's a -3. Y minus a -3 ends up being y plus 3 equals your m, 1/2, times x minus the x coordinate, which is 4. That's how you get that equation. All right, let's move on to a few more. They'll get a little bit more difficult, but let's check this out. It says here, write the equation of a line having an x-intercept of 7 and a slope of -3. Well, the slope is m, but what does it mean x-intercept? And it might be helpful if you just jot this down real quick. The x-intercept is out here at 7. Well, that's simply a coordinate. That's the coordinate 7, 0. So there's your x1, there's your y1. Y minus the y coordinate equals m, which you said was -3, times x minus the x. So I'm totally fine if you leave it like this. That's cool. Or if you wanted to, y minus 0 is the same thing as y. You could do this. That's cool too. Or you could even distribute here. All right, so it depends on how much math you feel like doing. Or y equals negative 3x plus 21. All of these would be acceptable. I'd probably, if I were you guys, just leave it like that. It's open-ended. It's not multiple choice. That's the equation. Example 5, write the equation of a line passing through 4, negative 7, and which is perpendicular. Challenging. So perpendicular, you have to remember, we have opposite reciprocal slopes. So we have to take a look at the slope of this and find the opposite reciprocal. So I'm going to negate it, which makes it positive, and I'm going to flip it. So that's 3 over 2. This will be my x1, that'll be my y1. So I'll take this slope, that's my m, that x1, that y1. Here we go. Y minus the y coordinate, since it's a negative 7, becomes plus 7, equals your slope, which is 3 halves, times x minus the x coordinate. Good. Example 6, write the equation of a line that passes through the points 3, 8 and negative 3, 5. Something's missing here, right? If we go back to the front, notice what both of these equations have. They both have slope. All right, so what I need to do here, it's a little bit of work, I need to find the slope. Well, we've got a slope formula. It's not that bad. Slope formula is y minus y, so we'll take 8 minus 5 over x minus x, 3 minus negative 3. 8 minus 5 is 3. 3 minus a negative 3 is 6. That's the same as 1/2. So there's my m. All right, I'll use that as my slope. And it's your pick. You can pick either one of these. I'll stick with this first one. I'll make that the x1, make that the y1. So y minus the y coordinate 8 equals my slope, which we just calculated, 1/2, times x minus the x coordinate. There's another equation that would work. You could use this point here and put the 5 in here and the negative 3 in here, which would make that a plus 3. So what you see here would also work. I just used the first one. 7, write the equation of a line passing through 3, negative 1 and negative 8, 5. This is very similar to one we just did. So we need to find the slope first. I'll go left to right. Negative 1 minus 5 over 3 minus negative 8. So that's negative 6, and that is, what, 11? So there's your slope. You can pick either point you want. I just usually go with the first one. There's x1, y1. So your equation, y minus the y coordinate, since it's a negative 1, that becomes plus 1, because you're subtracting, equals your slope, negative 6/11 times x minus the x coordinate, x minus 3. Okay, and the last one. Write the equation of a line having a y-intercept of negative 8 and passing through 6, negative 1. Well, I've got the y-intercept, but again, what's missing here is a slope. And I don't have another coordinate written out. I know 6, negative 1 is one of the two. But again, it might be helpful to sketch this. The y-intercept is negative 8. So way down here. That would be the point 0, negative 8. So if I want to find my slope, I would use these two y values here and then those two x values. All right, so how about it? We got negative 8 minus negative 1 over 0 minus 6. So that becomes addition. That's a negative 7 over a negative 6. Clean up those negatives. My slope is negative 7 over 6. So again, you've got a couple options. There's your slope, and they give you the y-intercept, so that's actually b. I'd probably go back to the y equals mx plus b. Y equals 7, 6, x minus 8. There are other versions that would work. If you wanted to, you can use this as x1 and y1. So you don't have to do both. I'll just show you. You could have done y minus a negative 1 or y plus 1 equals your m, 7 over 6 times x minus 6. What's kind of neat about this is that there's an infinite number of equations that will graph a single line, because you can pick any point you want on that line. There's an infinite number of points on that line. All right, guys, that concludes day 6. Thanks a lot for watching and filling in your notes. As usual, if you have any questions, don't hesitate to reach out and ask. We'll see you in class soon.